All right, so happy Friday, and we're off next Friday, so that's good. Yeah, test is next week. We don't have a block day next week. Let's look at notes for today. So looking at the notes packet, so go ahead and get that out. Yesterday we did graphing with r and theta, like graphing points r and theta. Today we're going to do equations with r and theta. So Thursday was points, Friday is equations with r and theta. And you can call them classic polar functions. You could also think of them as parent functions, right? Like you know what a parabola looks like, you know what a line looks like, you know what a circle looks like, you know what the square root looks like. At least I hope you know all those things. Those are the sort of the standard graphs in XY that you know. Today we're going to learn, or at least over the next few days, we're going to learn some parent functions in the polar realm. Today we're going to do circles and roses. And then Monday we'll do cardioids, and that looks like limacons, but it's a French word, limaçon. So it's fun to just say it fancy, limaçon. But we'll worry about that on Monday. Today is circles and roses, and so like just big picture overview. There's pictures of all of them right there. Obviously, you know what a circle is. But it might be centered at the origin, or it might be like the edge is on the origin, and it could be left or right, up or down. Roses, sometimes their petals are on the x-axis, and sometimes they're not. Cardioids, those look a little bit weird. We'll talk about those when we get there. Cardio. Recognize that word? Heart. And so, you know, if you stretch your imagination a little bit, that one looks like a heart. You're like, kinda. Like, well, maybe. But that's where the name comes from. I don't know where limaçon comes from. So that's big picture where we're headed. And in fact, that's most of the rest of the unit, is figuring out all of those different graphs. It's a lot of stuff, but there's some commonalities between all of them that once you learn sort of the hints and tricks of the trade, it'll speed things up pretty quickly. All right, today we're doing circles and roses. So circles look like an easy graph, and they are pretty simple. By the way, just say this at the beginning, no equations will be given on the test. So you do need to start to learn these. And again, whether you memorize them or you just sort of learn them as we go, but they're not going to be given on the test. Circles. Okay, three different, I guess, types of circles. R equals A. We saw that one yesterday in the notes. Circle centered at the origin with radius A. So circle centered at the origin with radius A. If R is 2, then we always start with the easiest thing, and this is the easiest thing. Radius is 2, means just go out 2 in all directions. And connect the dots with a circle, not a diamond. It's a pretty good circle for the first one of the day. And even if R equals -1, that feels weird because of the negative. And you could even think that you flip the circle. But if you flip a circle, it still looks the same. And you're like, well, I don't know which way to flip it. Like, I don't either, but it doesn't matter because it still looks like a circle with radius 1. So I don't want to say the negative doesn't matter. I would say the negative does what it always does. It flips it. But when you flip it, it doesn't do anything because it's a circle centered at the origin. So that's our favorite graph because that one's pretty easy. Okay, Okay, the second type of circle, A cosine theta, is a circle on the x-axis with diameter A. Okay, a couple things here. Cosine goes with x-axis. Right? That's cosine has gone with x all year long. Right? It's the x-coordinate on the unit circle. It was x something yesterday. Oh, and velocity is the x component. Here, graphing, if it's cosine, then it's going to have an x orientation. And that's going to be true for all of these graphs. So even though we don't know what a limacon is, like you look at that first limacon, that has an up and down orientation right there. So I know already that's a sine limacon. And that second one is a left and right thing, so that's a cosine limacon. So from now until forever, cosine goes with x, sine goes with y. Now, the trick is, let's go ahead and say the other one. So sine goes with y. The trick is, it's the diameter that is that number out front. So 3 cosine theta. It's going to be on the x-axis. You don't need to read all this stuff. This will make sense when we do it. This is going to be on the x-axis. So cosine means x-axis, and diameter equals 3. So we'll go out 3. And there's our circle. Next one, cosine. So I know it's on the x-axis. What do you think the -4 does? I mean, diameter is going to equal 4, but what does the negative usually do? Say it, somebody. Flip it. So instead of being on the right side, it's going to be on the left side. Okay, so I think this makes sense. Cosine is left and right. Negative means on the left. So let's count out 4 spots and put our circle over there. R equals 3 sine theta. So sine means it's going to be on the y-axis or have a y-axis orientation. Diameter is 3. Let's go up 3. And there's my circle. And then that last one, y-axis orientation, diameter 2, but negative means it's flipped, so we'll flip it to the bottom. And there we go. So circles aren't too bad. R equals is the easiest one. And then sine and cosine, just be careful that the number out front is the diameter. After that, it all kind of makes sense. Cosine is x, sine is y. Has been all year, continues to be that way today. Okay, roses. Roses get a little tricky because there's an extra variable thrown in there. So we're on the next page here. A rose looks like this. So let's write the circle equation right above it. R equals A cosine theta. So let me ask the easy question. Even though you don't know what a rose looks like, what is different about the equation?
N.
And there's an n in there. So like that's what is complicating things, is that n. Star here. Note the similarity of the equations to the circle. Yeah, it's pretty similar. In fact, well, we'll say that in a minute. The rose will have n petals if n is odd. The rose will have 2 n petals if n is even. I'm going to rearrange that because I feel like that's out of order. I'm going to say if n is odd, then it has n petals. If n is even, then it has 2 n petals. So that's kind of a weird deal. Like odd or even determines how many petals it has. So for a circle, it's sort of like n equals 1. Like there's not a number there, but it's sort of like n equals 1. That's odd. So it has one petal. And because it only has one petal, it's a circle. So a circle is the same thing as a one-petal rose. I mean, that's kind of a boring rose, but that's the link between the two. And that's one way to teach it is, oh, we're not really learning circles, we're just going to talk about roses. And it happens that a special case of the rose is that it only has one petal and then it's a circle. And so that's one way to sort of collapse and join the two things that we learned today. All right, cosine roses. They will have a petal on the x-axis. In fact, you'll have a petal on every axis, but I would just say you have a petal on the x-axis and go from there, because that way it ties together what we already know. Cosine goes with x. So if it's a cosine rose, you're going to have a petal on the x-axis. And always, all the petals are always equally spaced. So that it does happen that they'll be on every axis, but I prefer to just remember that cosine lands on the x-axis because cosine and x always go together. Draw the petals evenly around. If a is less than 0, it does not change the shape of the graph. Because if you flip it, it's kind of the same thing for a circle at the middle. If you flip a circle centered at the origin, it doesn't really do anything. Same thing here. If you flip something that already has all kinds of symmetry, then it doesn't matter. So 3 cosine 2 theta. Okay, n equals 2. Therefore, how many petals? Careful. If n is even, then 2n petals. So n is 2. We've got 4 petals. And it's cosine, so we've got a petal on the x-axis. That is 3 out there, or the length of the petal is 3. There's our first petal. Now, the 4 petals need to be equally spaced. Sometimes it gets tricky to figure out, like, what is the angle for an equally spaced petal. But I think with 4 petals, I hope that that's not hard to figure out, how to equally space 4 petals. So there's our 4-petaled rose. Now, the next one, cosine, so we're on the x-axis. 2 theta, so 4 petals. The negative flips it over the x-axis, so I guess you could say, well, this red petal really becomes this petal over here. And then you fill in the rest. And it's like, oh, well, it's the same picture as this one. If you graphed it in the calculator and you watch carefully like how the calculator traces it out, the trace would look different because of the negative, but at the end of the graph, they would look the same. Five cosine 4 theta. Okay, how many petals for this guy? 8 petals. And 1 on the x-axis. These are going to be narrow because the petals don't overlap. They always touch each other but don't overlap. So the more petals you have, the narrower they get. So to fit 8 petals in there, I'm going to make it a little bit narrower than the other one. So there's the first one. Let's see, let's equally space 8 petals. Well, we just did 4, so I'll start with the 4 and then as neatly and as nicely as possible sketch in 8. Preferably all of them having the same length. Like this, my bottom left one looks maybe a little long, but you get the idea. And I guess when we're graphing, we should indicate that that went out to 5. The length is 5. But once you do that once, I can tell that all of them have a length of 5. So you don't need to like label 5 everywhere. Just once is fine. How many petals is this next one going to have? 12, yes. Cosine, so we'll start with one on the x-axis. Oops. Okay, so there's my first 4. So I sort of need like 3 per quadrant. So I need to squeeze 2 more in between each of the 2 I already have. So again, it's a little bit of an artistic challenge here. And as long as you've got the right number of petals roughly drawn, I'm not going to get out a ruler or something and check the angles or check the lengths. Like if you put 4 on the first one, I'll know that you intend for all of them to be 4, and I can count to 12 and make sure they're like visually equally spaced. Right? If you put 8 of them on the right side and 4 of them on the left side, that's not good enough. But I'm not getting a protractor out to check your angles. All right, if n is odd and you have cosine, then you have a petal on the x-axis. Okay, we already said that. Cosine goes with the x-axis. So let's skip these directions. Let's jump down and just do one. 3 cosine 3 theta. So 3 petals, because n is odd. Cosine, so we'll put 1 on the x-axis. The trick is, now I have to equally space 3 of them. How many degrees is it all the way around? The full spin? Nobody wants to talk this morning? 360. So they should be 120 apart. Again, I don't expect you to get a protractor out and start measuring stuff, but that just gives you a little bit of a hint. Okay, it's got to be more than 90. That'd be about right here. So I'll put a petal there. And 240 would be about right there. So I'll put a petal there. Again, I'm not looking for perfection here. But if you draw 3 petals and your 3 petals look like that, well, that's going to lose points. Like, yeah, that's 3 petals, but those are not equally spaced. All right, next one, -3 cosine 5 theta. How many petals? 5 petals. What do you think the negative does? What's the negative always do? Flip it. So our first petal then is not on the positive x-axis, it's on the negative x-axis. So I'll put my first petal over there. And now I have to equally space 5 petals. Some people like have an intuition for like how to draw 5 equally spaced petals. Like it just, I don't know, their brain works more artistically than mine does. Some of us are like, I don't know, I got to just divide by 5 and figure out how far apart they are. So that's, goodness, 72. That doesn't have to be, again, whether yours is 70 or 72 or 75 or 80. That just gets you a ballpark of, okay, it's not quite 90, so I'll need 1 there. I'll need 1 there. Because those are, in theory, 72 degrees away from my first one. And then I need 2 more, sort of equally spaced on the other side. So these I'm kind of just eyeballing. But hey, that looks pretty good. A little starfish rose there. -5 cosine 3 theta. Do we need to do the last two? Are we okay? How many? Okay, we won't draw them. How many petals is this one? How many petals does it have? 3. Where's the first one? You guys are pointing. Yes, negative x-axis because of the negative. This one, how many petals will this last one have? 7. And where will the first one be? Positive x-axis. And then spacing 7 petals is a little bit weird, but 360 divided by 7, well, 350 divided by 7 is 50, so, 50-ish. Again, no one's going to be measuring these, so as long as you're in the ballpark. And again, people can eyeball them and be fine. All right, now let's go the other way here, see how well we've learned it. Write the equation of each graph below. Okay, well, let's see. I guess what do you notice first about this first one? You tell me. What's something that you see about that one? 3 petals. So n equals 3. So there's going to be a 3 theta in there somewhere. Okay, we don't say diameter, but yeah, I know what you mean. The length of the petal is 3. So this length is 3, so that's our how big the sort of the amplitude. I don't think that's exactly the right word, but it controls how big the rose is. So put a 3 out there. It's cosine because it's on the x-axis, and it's a positive cosine because it's on the positive x-axis. All right, the next one. Why don't you try the next 2? That last one's a little bit crazy, and you have to count and figure it out. But try the next 2. Okay, good deal. So you kind of got the hang of it. Turn the page. Sign roses. Okay, this is a little bit tricky because for sign roses, you would think that you have a petal on the y-axis, but you don't. And it's a little bit of an explanation as to why. The easiest answer is, what's the easiest way to say this? For a sign rose, let's say it this way. There's no petal on the x-axis because the x-axis belongs to cosine. So sine, you might have one on a y, you might not. Don't worry about that. You definitely don't ever have one on the x. That's probably the easiest way to remember it. So cosine goes with x, sine goes with not x, but it doesn't necessarily mean y. All right. All the petals lie in between the axis. Draw the petals evenly around. So r equals 3. A lot of these are the same, same thought process here. So if n equals 2, that means we've got 4 petals, but not on an axis. So I need to equally space petals, avoiding the axis. Okay, that was a little rough there, but again, you get the idea. How about that next one? It's negative. So if we flip it in the y direction because it's sine, how will that change the shape of my graph? Yeah, you're like, it won't. So the negative, again, doesn't really matter for this one because if I flip it, it still looks the same. By the way, if you ever watch the calculator graph one of these, it doesn't draw them one petal at a time. It draws them like this. Watch how I draw this. See if I can do this right. It sort of draws them like the old spirograph toy you had as a kid, where you stuck your pin in the thing and you did the little swirly deals. That's sort of how the calculator draws them. And that's because the calculator goes in order of it increases theta and it traces them out. So it doesn't draw them a petal at a time. It draws it like I just did. I left off. We need to indicate that that length is 3. So what you do is, to do that, you kind of just put like a radius out there and say that's 3. You don't have to label all of them. If you label one of them, I'll know what you mean. But you do need to label one of them so that I know that you know that that length is 3. How many petals on the next one? 8 petals. Equally spaced, avoiding the axes. So I guess that's just 2 per quadrant. Ooh, that wasn't my best effort there. By the way, the petals should not overlap like that. That's a mistake on my part. They should be tangent to each other, right up next to each other, but not overlapping like that. So that's not exactly right. And that radius is 5, so we can put a little sort of marker out there to indicate that those are 5 long. All right, now to further complicate our rules, if n is odd and you have a sign, then you have 1 petal on the y-axis. I like how we start this. We know this one's a circle. We know what a circle looks like. 4 sine theta. Sine goes on the y-axis. Fine, 1 petal. But if it's 3, it's on the bottom one. If it's 5, it's on the... You're not going to have to remember this, because if it gets this complicated, it's going to be sort of a multiple choice. Yeah, like how you know where the first petal is well, it's not, yeah, I don't want to, it's not worth talking about. It takes too long to explain. You won't have to know how to graph sine roses with odd number of petals. There you go. Because it's just, there's too much going on. It's too crazy. But you do need to recognize them when you see them. So, like number 1, let's see. 5 petals. So, no, it's not either A or B. What about C or D? Is it a cosine or a sine? Sine, because there's not one on the x-axis. Number 2, there's not one on the x-axis while I'm thinking about that, so it's not a cosine. There's 3 petals, so it's A. Number 3, 3 petals. Sine or cosine? Cosine. Why do you know it's cosine?
Because there's one on the x-axis.
Because there's one on the x-axis. So that means it's cosine. So cosine 3 theta would be C. Goodness, that last one. Well, there's definitely not 3 petals, so I can throw that out. There's 11 petals. I didn't even count them. I just elimination here. Is it a cosine rose or a sine rose? Good, sine, because there's not one on the x-axis, so it's not cosine. It's got to be sine. So cosine always on the x-axis, maybe the negative x-axis, and it turns out that it's on all the axes. Sine is not on the x-axis. Never one on the x-axis. After that, you can kind of figure it out from there. Okay, today's assignment is whatever worksheet is next. Worksheet 4, I think. And again, lots of cosines, because we know you can graph those. The sines will have an even number of petals. That way you can graph those. And then on the back page is sort of going the other way. We give you the picture, and you come up with the equation. And a few of them have multiple answers, but we saw that earlier.